This is going to be a little bit of a different kind of video. This is going to be more of a podcast series. So let me know what you guys think of this type of video or podcast. And yeah, maybe I'll do more of them. So the way I'm going to structure this is, well, I asked ChatGPT to give me just some questions about software development. And I'm just going to kind of give my take on each of those. So if you like this video, make sure to let me know in the comments. And yeah, let's jump right in. All right. So okay. First question is, so what are some common challenges intermediate developers face when transitioning from a beginner to a more advanced level? How can these challenges be addressed? Yeah, this is an interesting question. So I think the big thing when you're going from beginner to intermediate is when you're a beginner, there seems to be a lot more resources available, kind of more general purpose, how to learn programming, how to learn HTML, CSS, and so forth. When you get to a more intermediate stage, your problems that you need to solve become more nuanced. So it becomes harder to find resources on your specific topic. So oftentimes going from beginner to intermediate, or at least in my case, I relied a lot on, let's say YouTube tutorials or books or podcasts and things like that. And when you go to the intermediate stage, a lot of times you have to transition more into probably looking at more documentation for the specific tool that you're using, or, trying to figure things out, maybe even sometimes looking at the source code, if it's an open source tool, or, trying to just figure out what the issue is with looking through GitHub issues and so on and so forth. So yeah, I would say that's kind of like the biggest thing I can think of, is that when you are a beginner, there's often a lot more resources and tutorials that are kind of more general purpose. But when you're an intermediate, or get to that kind of intermediate stage, then um, the problems you're facing are a bit more nuanced, and you have to be a little bit more resourceful or clever and kind of or creative on how you kind of approach it. And it might involve, looking through documentation, or um, kind of trying to kind of frame the problem in a different way to see how you can figure it out. But there is an important caveat here, is now that ChatGPT has become more mainstream, I think these problems should be alleviated more. Meaning, with something like ChatGPT, as an intermediate developer, I think it's much easier to ask ChatGPT your very specific and nuanced question, and a lot of times you can get a pretty reasonable answer pretty quickly. Um, so my advice, and this probably is the same advice if you're a beginner as well, would be to ask ChatGPT, like, see, in plain English, ask ChatGPT what's going on. Try to provide some context that you can, and see what you can come up with. I feel like that will be that's a method that I will definitely be using to learn new tools. And like these days when I'm looking, like when I see a page of documentation, I'm like, no, not doing it. I just go to ChatGPT and I'm like, hey, this is what I'm trying to do. Can you just help me figure this out? And then it'll be like, yep, here's how you do it. Step 1, go here. Step 2, go here. So um, that if you haven't checked out ChatGPT, that's what I would recommend, kind of first and foremost. But that's kind of my long-winded answer to this. Okay, so problem or question number 2. Can you discuss the importance of clean code and best practices in software development? How can following these principles lead to more maintainable code? So, so here's the thing with clean code. Clean code is always going to be subjective. There's going to be people that prefer styling it a certain way, and there's going to be people that prefer styling it another way. However, in general, clean code can just breed consistency throughout the project. Like if you are in a JavaScript project, for example, I always like to use, a linter or a like prettier in order to just take all the guesswork out of what defines clean code for that particular project. And then your editor can just format on save, or you can set up your editor so that every time you save your file, it just automatically formats. So you as a developer don't have to think about, the white space necessary, to some degree. To some degree, you kind of have to think about it, but you don't have to think about like the indentation, or if you're using tabs or spaces. You just save it, whatever the configuration is set up for for that project is kind of what you're going to roll with. So that's kind of my suggestion is, or I guess that's my take is that clean code is going to be subjective. It's like, what is clean code is going to depend on the project. So with that being said, like if you are jumping into a new project that's, been developed for some time, just go with the style that has already been established in the project. I wouldn't recommend going into a project that kind of has standards established and, formatting rules established, and then try to deviate from them or introduce your own rules. Just go in there and, make it look consistent. So what is clean code? I think probably there's like a degree of consistency with it, and it is easy to visually scan the code and get an idea of what is going on in the code. So for example, if you are looking at completely minified JavaScript, so like the entire application is just on one single line of code, and then you are asked to debug that program, that would be very, very hard to do. But if that same program was, cleanly indented, there's some vertical white space, some horizontal white space, you can kind of see the control flow easily, the if statements, the loops, etc. Then it would be much easier to figure out what that program is doing. So that's kind of, in my mind, when I hear clean code, is like, can I look at this code and understand how things are kind of structured? That also ties in with things like how you're naming your variables, for example. So can I look at a variable name and understand what this variable name contains, or is it cryptic? Is it like uh, uh, like is variable name X versus variable name like items added to shopping cart, like something that's very descriptive. So that's kind of my take on clean code. And again, it's basically, can you understand what's the basic idea of what's going on by looking at it? Like, how long does it take? Maybe there's a correlation. It's like, how long does it take to understand the code, and how clean the code is. And then that's the other thing, is that clean code is ultimately subjective. Some people are going to prefer semicolons. Some people are not going to prefer them. Some people are going to want tabs. Some people are going to want spaces. I would say, just if you're starting a new project, get a tool like Prettier to just establish some guidelines, and then you can set up your editor so that every time you save the file, it just auto formats it based on those rules, and you don't really have to think about it too much. If you're working in a project that's already, in the wild, just use they first of all, they might already have like linting and formatting tools in the project. So if they do, great, then use those tools. If they don't have them, just try to match the style that is kind of already being used in the project. If the project doesn't have any linting or formatting rules set up, and the project is like the Wild West, and there is no kind of consistency, and it just is all, it's just all a mess, and everybody's doing their own thing. Well, in that case, I guess, I guess you have the freedom to kind of write the code the way you want. So I would say, just, when you write your code, just, make it as neat as possible, and, as clean as possible, the way that you think it is. Because the thing is when you write code and you commit it, to Git, then whenever someone runs Git blame, they'll be able to see like that, hey, you wrote this code, and you're going to be the one that they're going to come to if there's a problem with the code. So even if the code that, or the project you're working with, is kind of a mess, I would say, still, you want to do your best job and make, good, follow like what you think are good practices. Hold on, I need to charge my phone. All right, so one last kind of point I'll make about kind of clean code. If you're kind of new to this and you kind of want to get some ideas on what is clean code, at least what could be considered clean code, I recommend checking out the book by, the author's name is Uncle Bob Martin. Check out the book called Clean Code. Let me open it up here. Yeah, take a look at this book, or take a read of this Clean Code. The examples are in Java, but it you can kind of follow these principles, take them with you. And then what I always say is like this book is sometimes criticized as like a little too extreme. And I remember when I first read this book, it was when I was in college, and I was like, well, first of all, I really liked the book, and I thought the ideas were really good. Like basically in this book, he writes like one line of code per function, and like all the functions have like really descriptive names. And so I started doing that in like my school projects. And like, first of all, I really liked it. I really liked doing that, especially because like whenever you had an error, you could like see the stack trace and really clearly see like the kind of code path, because like all the functions were so short, so you could just like see exactly like where the code went. So I actually thought that writing the code in the way that's kind of described in this book was actually really helpful. But I remember the TA that graded that assignment. Now, first of all, when I turned it in, I was like so proud of it. I was like, man, this code is so beautiful. I love this code. This is great. I remember turning it in. The TA was like, "What are you doing? Like, can you please not extract every single thing into a line of into a separate function, because this is so hard for me to grade." They're like, "Can you please just like write more lines of code inside of a single function? Like, it's okay." And I remember getting that feedback and being like, interesting. So kind of shows an example of like how there is just difference of opinions here on like what is clean code. Um, so my advice here is like I would still read the book, and then kind of have your own mind about like, okay, this is one person's opinion on what clean code is. Like, what's my opinion on clean code? Like, what would I think is the most maintainable way here to write this code? Um, and since I've read this book, I've kind of backed off of following the principles outlined in his book, and I write more code inside of a single function. Hopefully, my TA will be proud of that. But yeah, again, it's gonna depend on the person. Like, I very well could have wrote that function at school and wrote it with let's say 20 lines of code per function, and I could have had a TA that has read the clean code book and liked those principles and decided, hey, you know what, I wanted more abstraction. So yeah, I would say there's kind of a balancing act here. But ultimately, like when I think of clean code, like what am I'm just kind of thinking of like maintainability. How can I come into this code base a year from now and have some idea of what's going on? Can I come into this code base a year from now and confidently make changes? And so those are the kind of things that I kind of think of, kind of correlates with clean code. Okay, so the next question. So how can developers effectively leverage design patterns in their work? Can you provide examples of some popular design patterns and their practical use cases? All right, so first of all, design patterns. So when I hear the word or words design patterns, the first thing that comes to my mind is the book written. It's commonly referred to as the Gang of Four, and they have a book on design patterns. This is kind of the kind of colloquial book on writing design patterns in like a object-oriented programming paradigm. So, like, if we're asking the question, like, what are some design patterns? Take a look at this book, or take a read here of this book. It's an older book, and like I think there was a book by the Head First series. Whoops. Yeah, so then there was this Head First design patterns, which is a little bit newer and maybe a little bit more of a kind of, I don't know, I guess user friendly type of book. But yeah, take a look. That this will teach you some design patterns. I think they use Java in these books. At least Java for the Head First book. The Gang of Four, maybe it's Smalltalk, but it's some object oriented paradigm. But if you read a book like this will teach you some of the common design patterns. Now, um, how can you leverage the design patterns? I think this is kind of like the clean code thing, or it kind of makes me think of the clean code. When I read clean code again, when I read clean code, I wanted to apply the clean code principles, or that the principles that were taught in the book by Bob Martin, kind of all over the place, and like in any way that I could. It's kind of a similar thing. And when you read about design patterns, say from a book like the Gang of Four's book, or like the Head First design patterns, you are kind of tempted to like try to shoehorn design patterns kind of everywhere you possibly can. And you know what? Like, I'm gonna make the argument that like that's okay. Like, you know, when you first are learning about the design patterns, you know, try to put them in everywhere you can. But here's the thing, you know, the, all right. So let me like rephrase this, because if you're working on a team, if you're like at work, and you know, I guess it's a kind of a different story. You kind of want to be professional, and not, but if it's your own project, and you're just learning and you're just experimenting, yeah, try design patterns everywhere you can. And yes, it'll probably be overkill a lot of the times, but you will kind of pick up like where the design patterns seem to be effective, and where they are a bit overkill. Um, and you will kind of get a sense over time of like this is this is like the pattern that I think could help us solve a problem. Um, so like I'll give you like one example here. So in object-oriented programming, there's this kind of term of inheritance, where you can have like, for example, a common example that's given is like you have an animal object, and then you have like a dog object, and the animal object has these properties on it, that a dog also has. So the dog can inherit from the animal object. And so then you can kind of get some code reuse out of that, because you can just write the code that's common to all animals in the animal object, and then the dog object that inherits from it um, can reuse that code. And it only has to add the code that is specific to the dog object. There's this other pattern called composition. And basically, what it is talking about is like you can use other objects, maybe objects that are unrelated to each other, um, in order to solve a particular problem. So I'll give you an example. So let's say you have like a point object, so like a mathematical point object. So you could have like a 2D point, which is has like coordinates x and y on that object. And then you might want to have a 3D point object, which would have an x, y, and z. So if you were going to take an inheritance approach, you might think that you could extend the 2D point for the 3D point. So for example, like the 3D point extends the 2D point, so that we get the code reuse from the x and the y. And then in our 3D point, all we need to add is the z property, and we can kind of go about our business. But that is actually not the the correct way. I'm just gonna say, like, it's not the correct way to approach that particular thing, because anytime you're doing inheritance, you should ask, like, so if A is extending B, you should ask, is A B? Okay, that was too abstract, probably very confusing. So let me use my dog example. So, is a dog an animal? If so, if yes, then you can use inheritance. But if it's not that thing, then you shouldn't use inheritance. And you should maybe think about something like composition. So, for example, is a 3D point a 2D point? No. A 2D point is a 2D point. A 3D point is in, a point in three-dimensional space. A 2D point is a point in two-dimensional space. They are both points, yes, but a 3D point is not a 2D point. So we wouldn't use inheritance there, but we could use composition. And so with composition, what you would do is, for example, internally in the implementation of the 3D point could have a private instance of a 2D point. So what do I mean by that? Basically, we can use the functionality of the 2D point internally inside of the 3D point, but there's no like inheritance relationship. We're not making the claim that the 2D or the 3D point is the 2D point. So I feel like I'm saying like point so much that it's starting to sound weird to me, but hopefully you kind of get the idea of what I mean, and kind of the like stepping out back to the question of kind of like how can you effectively leverage design patterns. I would say my advice here is like, first of all, if you have no idea kind of like about design patterns, read one of these books like the Gang of Four's design pattern book, or the Head First design pattern book. Get an idea of kind of like what's out there as like design patterns, and then try using them. If you're at work and you feel like there is a good use to it, call it out, put it up for a pull request, and see what your team thinks about your usage of that design pattern. You can even call it out. You can say, hey, like this here, I'm using the builder pattern in order to do such and such task. And hopefully you have some experienced developers on your team, and if it's maybe it's not the right pattern or not the right design pattern, then they'll call it out and say like, hey, you know what, this is a little bit not the right use of this design pattern. But I would say experiment with it. Don't try. I encourage you to kind of go overboard with it. In order to learn, and then you can dial it back to kind of like you just kind of like learn like where those design patterns actually worked and where they seem like they might work, but they don't end up working. And yeah, that's probably my advice there. And kind of another thing to keep in mind about design patterns is they're gonna like the design patterns are often language specific. So in Java, there are a set of design patterns that are commonly used in Java. Java is an object-oriented programming language, after all. And in other object-oriented programming languages, say Ruby, you might get similar design patterns as in Java because they're kind of using this similar paradigm. But there will be design patterns in Ruby that are not part of kind of in the like realm of possible design patterns in Java. And that's because Ruby is a dynamically typed language and Java is a statically typed language. So what I'm saying is like the design patterns will change based on kind of what environment you're in. Like if you are in a functional programming uh if you're in a functional programming language, that will have a set of design patterns that are common that have like nothing to do with a programming language that's an object oriented language. Um, so, when you learn a language, oftentimes the language will have, or the community that kind of supports the language will kind of have an established pattern, or design patterns that are kind of encouraged by the language. For example, in Golang is not really an object oriented programming language, but it has object oriented, like you can kind of achieve object oriented programming paradigms inside of Go, but it's not exactly the way you would do it in Java, for example. Inside of Golang as one example, there is no like concept of inheritance, but there are certain patterns you can do in Go to kind of get the effect of inheritance or the effect of polymorphism. So yeah, it'll be different from language to language, but I do still think that like checking out the Gang of Fours book or the head first series is a great starting place to learn, and then from there, depending on kind of what language you're using, it should give you like a good foundation to kind of start on. Okay, so that was a lot. All right, so it looks like we're heading into 34 minutes. I'll probably go for like 1 hour here. Okay, so let's see. What are some tips for debugging and troubleshooting in a large code base? What tools or techniques can help developers identify and fix issues more efficiently? So, some tips for debugging and troubleshooting in a large code base. That's a good question. So I would say, all right, there's a couple of different ways we can go with this, but first thing is try to see if someone else has solved this problem at your organization before you. And so what do I mean by that? Let's say you're like looking at some configuration YAML file and you're going to be adding some configuration for some service or whatever. It doesn't really matter. But you have not worked with this type of configuration file before, so you don't really know like what the structure is. Perhaps there is somewhere in that configuration file, like someone probably has done what you're doing today in the past. So see if you can find an example of what someone, or like see if you can find an example of like what you want to do in the code base. That should give you a idea of like how you might want to solve the problem. um so that's like one example. Like if like say you're doing a configuration file, maybe like if you like scroll up a little bit, you'll see like, oh, this is, yeah, it looks like this is exactly like what I want to do. And based on that, you could go further. You could say like, okay, like look up maybe like what those properties, what those properties mean, but so that's one thing. Is looking at uh old or looking at the code that's already there and see if you can kind of get some clues from that. Option two, let's say you are in the code base. You don't know what's what. You're in some file. Maybe it's, maybe you're on some team and you're working. You have to work in some other team's code for whatever reason. Then another option or another strategy here is check get blame. So in IntelliJ, that's the editor I use. You can just like right click on one of the lines of code, and you could say like open. I think it's like open Git annotations, and you can see like who committed that code. And what that does is it'll give you an idea of like, Joe, Joe over here, like, must be pretty familiar with this code base because they've committed a lot of code to this code base recently, or to this like file recently. So let me go ask Joe. Let me go see, maybe Joe has like some ideas on like what I need to do here. Don't be afraid to talk to people and ask people questions. Like, I think a lot of times when we get to be more senior in our roles, I'm saying we, but I guess I'm really just talking like from personal experience here. Like, I'm gonna just say I feel like I should be able to figure this out because I'm more senior now, and like I'm smart, like I can figure this out. Like I don't need help, but like whenever I think about when I think that way, this is what I try to say. Like, if I was, let's say I wasn't at this like big company, let's say instead I like what I'm working on, I'm just at like a 2-person startup with my friend or my friends. If I was at a 2-person, 3-person, whatever startup, would I like try like stumble on a problem for like a really long time just so I can like figure it out myself? Or would I just ask the person sitting across the desk from me, like, hey, like, hey Joe, what's going on? What's going on with this code? Like, can you help me understand this code? I mean, like everything here, like pretty much everything with software is like of course there's a balance here, and you want to have a mind of your own. You don't want to just like always offload your questions and problems onto other people, but it's like you can just save so much time by just talking to people rather than trying to just figure out everything yourself, because there's just so much code oftentimes in a large company's code base that you just can't know every single thing that's going on everywhere. It's just not a good use of time. So talk to people. Don't be like don't be shy. Just go, ask them, what's going on with this code. And if you like that strategy of like putting yourself in the mindset of like, let's say I'm a founder where it's a 3-person startup, we're us 3 are founders of this company. Like, would we not talk to each other? Would we just be trying to figure things out ourselves? Like, of course not. We would be talking with each other, working with each other, trying to figure things out together. And then you get the added benefit of you meet people and build relationships with people, and, they help you. And then, down the line that, they might come to you, ask you for help on some code that you wrote. So, ask people questions. that's my tip for debugging and troubleshooting in a large code base. Ask people questions. Like, again, look for examples of, has your problem been solved before? Maybe you can get an idea of how to solve it yourself then. Um, if you know if that's not possible, see if you can open up Git blame and see, maybe you can get an idea of like who works on this code base regularly. Maybe I can just ask them, what's going on here. If either of those problems or if either of those solutions don't kind of fit your need, so let's say you're working on some greenfield project and that you are the only developer that knows about this code, this you can't like get blamed because it just shows your name and so this is a fresh problem. You got to figure it out for yourself. So what do you do at that point? ChatGPT. No, but seriously though, no, actually I am serious. Yeah, just ask ChatGPT or just look it up online somewhere. Try to figure out, try to frame your what is the question you're having and try to figure out. But I think this question seems to be like, how do you kind of deal with like more legacy code? If we're talking about a large code base, I'm thinking of code that kind of like already exists. Another kind of idea that just came to mind here for large code bases, and let's say you are debugging, troubleshooting, having issues. Maybe it's a sign that there's some tech debt. Maybe it's a sign that, the team needs to refactor and clean some things up, going back to the clean code discussion. So yeah. Those are my ideas there. All right. So I think I'll do one more and then I'll drop off here. But before I do it, how are you guys liking this content? Like if you if you've been here for 45 minutes, I mean, hopefully you're enjoying it. If not, then I applaud you for your patience and your willingness to hear me spiel for this long. So I guess if you've been here this long, and if you haven't already, make sure to like and subscribe. I think I'm gonna launch this on YouTube if it seems like this is something that people want more of. They want it, and like the official podcast channels. Let me know, and then I'll take the time to do it. But I'm kind of doing a soft launch here. So yeah. Okay, so let's do one more. So, okay, so how can developers improve their skills in a specific programming language or framework? What resources, projects, or communities do you recommend for learning and growth? I would say do a project that is interesting to you. Do a project that solves a real problem for you. When I'm working on a project that is a interesting problem to me, or it's that I find interesting, like I just love coding and like coding it up, and it's very like enjoyable for me. Like my blog skies.dev, for example, like I had a lot of fun just building that, tinkering with it, doing clean code, or at least what I thought was clean code. I don't, maybe my TA wouldn't agree, but yeah, pick a project that you find interesting and use different tools that you're not used to. And I would say that is an effective way to learn things. I mean, I know like I've worked on like projects, like side projects, learning things, and like the skills that I've gotten from doing those projects came like proved to be useful like in my day job. So, like let's say you want to learn about Rust programming. Like what is something you can do with the Rust programming language that, that would interest you, and do that. And or maybe it doesn't even have to be a project. Like maybe you just are interested in like following a tutorial. Like again, let's go back to Rust. Like Rust has a tutorial thing. Like I forget exactly what let me find it. It's like Rust tutorial. Let me see, rustlang.org. Yeah, so they have a like step by step, I think it's like an interactive like tutorial thing that you can learn, and maybe that's a way that you'd be interested. So there's several ways that you can kind of go about this, and it really just depends on the framework or the tool. Like I'm from, if you watch some of my content, that I'm a big Tailwind CSS fan, and like they have a Tailwind CSS official Discord channel, so that's a great place to go and talk with the Tailwind CSS community. You can even chat with some of the core team developers, and so yeah, see if like the project or framework that you're interested in has a community like that, like a Discord community. And you can talk with them that way. You can go to the GitHub, open the GitHub project, and they might have like a discussions tab or something like that, where you can open up a discussion and chat with the community that way. This is going to depend on your learning style. Are there, maybe you like watching YouTube tutorials on frameworks. You could check out like Traversy Media, Brad Traversy, and he's got excellent tutorials on different frameworks, like hour long, 2 hour long tutorials to kind of deep dive and get started on a particular framework. So maybe that's your style. Maybe books are your style. I really like books because I really like how it's just like very curated, and it's usually just like it's really, yeah, it's I think that's mainly what it is, just like curated information. I don't have to like go all over the place and try to like piece it all together. It's like, here is a block of information about a particular tool or whatnot. So so videos, books, creating projects that you're that you would find interesting. Maybe it's like creating a blog website, or maybe it's some way to make money, like a website that could potentially make you some money. Or maybe there's like a Discord channel, or go to GitHub discussions, things like that. So there's a handful of ways to learn about tools and frameworks. There's a handful of ways to kind of get involved, ask questions, and whatnot. So yeah, so I think that's where I'm gonna hop off from here. So again, thanks for watching my super long podcast video thing. Yeah, let me know what you guys thought of this podcast. And yeah, I'll catch you guys on the flip side, and yeah, peace.